On September 2nd, a launch window was opened for that spacecraft's initial flight, which will send people to the moon for the first time since 1972. A launch window is the time frame in which a rocket must be launched in order to reach its destination. But due to fuel leaks, this launch is postponed again. Now, if all goes according to plan, the Artemis mission will resume its plan to send astronauts back to the moon in 2025. The sister of Apollo by the name of Artemis is said to be the daughter of Zeus in Greek mythology. The goal of the initiative is to establish a permanent human presence on our nearest neighboring star and subsequently explore even more. The first of multiple missions is called Artemis-1. It holds the Space Launch System, SLS, a brand new super heavy rocket from NASA, and the Orion Multi-Purpose Crew Vehicle, or Orion MPCV, which has already made one space flight. The Orion MPCV is a solar-powered system, in contrast to the command service module of the Apollo missions, which was powered by hydrogen fuel cells. During challenging maneuvers, the vehicle's characteristic X-wing solar arrays can be swung forward or backward to lessen pressure. 6 astronauts could travel in orbit with it for 21 days. Without a crew, the Artemis-1 mission may last 42 days. Artemis, unlike Apollo, is a global endeavor. The Orion MPCV is made up of an astronaut capsule made in the US and a service module made in Europe that provides fuel, water, air, solar panels, and rocket engines. Because Artemis depends on the sun for power, certain factors must be taken into account when deciding when to launch it. For example, the Earth and Moon's positions at that time must be such that the Orion spacecraft will always be farther away from the sun than 90 minutes at any given time. Avoid remaining in the shade. In general, any spacecraft's launch is one of the riskiest phases, especially for a brand new rocket. A significant accomplishment for the project will be made if Artemis-1 successfully enters Earth orbit. 10 CubeSats, or tiny satellites, will also be launched into space by Orion during the voyage. One of these, BioSentinel, will contain yeast to observe how the lunar microgravity and radiation conditions affect microbial growth. Another, the NEA Scout, will launch a solar sail before heading to an asteroid nearby. IceCube will orbit the moon in the interim and look for ice deposits on or near the surface that future astronauts might use. Just 60 miles will separate the moon's surface from the point of entry into its orbit. To slow the spaceship down and help the moon's gravity hold it into orbit, Orion will fire its onboard thrusters. It will go in the opposite direction of the moon's orbit, which is unusually far away and retrograde. In this phase, Orion will travel 70,000 kilometers from the moon, the distance from Earth at which a spacecraft capable of carrying humans may travel. The view of the Earth and the moon would be spectacular for the astronauts if they were inside. Orion will orbit the moon for 6 to 23 days before firing its onboard engines once more to leave the moon's orbit and reposition itself on a course toward Earth. The moon's surface may get as hot as 120 degrees centigrade during the day and as cold as -170 degrees centigrade at night. The Orion spacecraft is constructed with materials capable of withstanding considerable thermal pressures without fail, since such big temperature fluctuations can result in significant thermal expansion and contraction of materials. Investigating this is one of the mission's objectives, and it is essential to make sure that the environment within the capsule is kept breathable at all times. Astronauts would also be outside of Earth's magnetic field, which typically protects us from cosmic radiation, at the distance of the moon. Any future manned expedition to the moon should be extremely cautious about deep space radiation. In comparison to Orion's planned stay in deep space, the longest Apollo mission, Apollo 17, lasted 12.5 days. Engineers will therefore closely monitor the radiation environment within the capsule. The Orion crew capsule will depart from the service module, which will then be let go and land on Earth. It will then enter an atmosphere shielded by its heat shield. It will touch down and dive into the water using a parachute. In reality, it is crucial to the mission's success since it guarantees that the capsule will survive the fast re-entry speed of a spacecraft returning from the moon and land without incident. When Orion's speed falls below 24,500 miles per hour, the heat shield must withstand temperatures of 2,750 degrees Celsius to do this. If the launch on August 29 goes well, splashdown will happen on October 10. 4 astronauts will go aboard the Artemis-2 spacecraft, which will launch in 2024 and travel 9,000 kilometers over the moon. On board Artemis-2, astronauts will travel the farthest away from Earth that anyone has ever done. For the first moon landing mission, Artemis-1, which plans to send people there in 2025, NASA has also unveiled a short list of potential landing locations close to the moon's south pole. Ultimately, whether they succeed in achieving that aim will rely on Artemis-1's ability to properly complete all of its planned processes.